Okay, here we go. Our goal today is to graph secant and cosecant. The graphs are going to look impossible. They're really no big deal. And this is the most important thing you have to start with as you graph secant and cosecant. We start by graphing sine and cosine. Okay? So when you see y is equal to cosecant, I don't start to think about cosecant. What I do is I start to think about this. Y is equal to sine of x. So in case you're still a little bit confused about sine or cosine, you get another day today to kind of think about that and review that. So I'm going to start by graphing sine and cosine, and that's going to allow us to be able to fill in these pieces here. But when I start with y is equal to sine of x, just note that we always said that the amplitude is what? Period is 2 pi. Very good. Very good. The amplitude is 1. So what we're trying to produce right now are the parent function graphs for it, and then we'll do 3 graphs after that have some transformations. So I heard that the amplitude was 1. I'm not going to put it all the way at the top. I'm going to need some space at the top. And even though we're not graphing sine of x, we're trying to graph cosecant, I have to start with the graph of sine of x. I have to start because it's the reciprocal. Sine and cosecant are reciprocals. So what I'm going to do here is I'm going to just briefly sketch the graph of sine. Does it start in the max, min, or middle? Starts in the middle, yep. And then it heads up. I'm just going to do a dashed line, kind of like a little bit of a ghost graph. This is good tying to our work yesterday. This is the big idea that you have to kind of think through today. Once you think through this, you're going to be absolutely fine. Again, that is not the graph of cosecant. We don't have the graph of cosecant yet. In order to get the graph of cosecant, I got to think about sine of x first. Look at where sine of x is equal to 0. Sine is equal to 0 at 0. Where else is it equal to 0? Pi. Where else? 2 pi. Yeah, and then those negative values. So that's where sine's equal to 0. 0 is a number like, say, 0 over 1. What's the reciprocal of 0 over 1? 1 over 0. And what is 1 over 0? If you have 0 in the denominator, you get undefined. See that? Look here. 0 over 1 is 0. 1 over 0 is undefined. Do you remember what we drew yesterday, or a couple days ago, when we did tangent and cotangent? Remember what we drew when you had undefined values? We drew asymptotes. Remember those? So here's what we're going to do. If sine is equal to 0 at those spots, then cosecant's undefined at those spots. So it ends up making it really simple way to be able to draw this graph. I look at the sine graph, and wherever I see it cross over 0, I draw vertical asymptotes. Don't like the sound. And the dog lick. Okay, so anyway, let's figure this out now. I still haven't drawn the graph of cosecant, but I'm ready to. What is the height of the graph here? 1. What's the reciprocal of 1? Everybody agree that that's 1? If we flip that upside down, you get that. What's the reciprocal of 1? 1. So cosecant and sine have the same value there. So then it heads up towards these asymptotes. That's part of the graph of cosecant. You see this spot right here. It's right at the top. We've got a dot there, and then it goes up. What's the height of the function here? -1. Anybody know what the reciprocal of -1 is? -1. So, all the stuff that you have drawn there isn't actually part of the graph. It just helps us draw the graph. It's the black part that's the actual graph. That's the graph of cosecant. I mean, when you see it, like, I mean, if you were doing your homework in front of, like, your parents and stuff, they'd be like, holy cow, that's really challenging stuff. You must be extremely intelligent. We're going to send you to Harvard, right? When you're like, it's no big deal, Mom. It's just the graph of sine, and then you flip it, right? You never say it like that. Okay, I got you. All right, let's try secant now. So I've got 1 and I've got -1. And the period is still, we're going to mark off 2 pi. Tanner, you ask an excellent question, and I will answer that question on the next problem. How's that? That was Joshua. What'd you have for supper last night, Josh? I made enchiladas, some chicken enchiladas. Oh, were they good? When you're going to graph secant, you don't graph secant, you graph cosine. Because cosine and secant are reciprocals of each other. Secant and cosine are reciprocals of each other. Where does cosine start? Yep, starts right up here. Okay. Where does it look like cosine is equal to 0? Good. Pi over 2, 3 pi over 2, so on and so forth. So that means that secant will be undefined at those spots because the reciprocal of 0 is undefined. So all we're going to do is take those spots for secant, and we're going to draw these vertical asymptotes right there. Anybody want to guess what I do now? Yeah, make some of those weird U shapes. Excellent. Devarian asks a great question. He said, are they like parabolas? They are like parabolas in that they have a general U shape. The difference is that a parabola will eventually go out to every spot on the side. So it's not bounded at all. Where these are bounded on the sides. Like there's a point where they never go out any further. See the difference? Yeah, so that's kind of what happens. What do you think? Can we do this? That's all right. Monday's optional. Yep. Okay, I'm going to switch the problem. We're going to do y is equal to 2 cosecant of x over 3. So what I do first is I don't graph cosecant. I instead start by graphing y is equal to 2 sine of x over 3. And the reason why I do 2 sine of x over 3 is that cosecant and sine are reciprocals. That's something you got to be able to think through and figure out. Memorize, mark on your chart, something. So let's decide what the amplitude is and what the period is. Amplitude is 2. So says Izzy, she's correct. How about the period? How do I determine the period here? I take 2 pi and I divide it by what? 1/3. 1/3. If you take 2 pi and divide it by 1/3, you get 6 pi. So I'm now going to make the structure of my graph. Question. So I don't want to put 2 all the way at the top because I have to have room for my graph. So I'm going to go 1 and 2, -1 and -2. 6 pi. What do I get if I divide 6 pi in half? What do you get if you divide 3 pi in half? 3 pi over 2. Good. What do I do to the first tick mark to get the third tick mark? Yeah, 9 pi over 2. I'm going to put that same thing on the other side. Okay, you tell me, where do I start? Do I go up or down? Nikki, you asked a really good question. She give you a good answer? Good. Anybody know what I do next? Make the asymptotes. And the asymptotes just go, yeah, where it crosses here. Now what? Draw your U-shapes. That's it. Instead of graphing secant, what do I graph? Cosine. Y equals -3 cosine of 2x. What's the amplitude? What's the period? 2 pi divided by 2 is pi. One, two, three. 1, 2, 3. Notice how I try to leave space to see the rest. Period is pi. What's pi divided by 2? Pi over 2. What's half of pi over 2? Pi over 4. So what's the third tick mark? 3 pi over 4. Where do I start? Why? Yeah, cosine starts the max or the min, and because it's negative, I start at the minimum. Now what should I do? Mark the asymptotes. And now, make my U-shapes. Okay, we're not going to do the last example. It's for a different time. I'm going to hand you your worksheet, and we need to make some changes to your worksheet. Everybody ready? We don't want to do vertical shifts and horizontal shifts. So therefore, this will be y is equal to 2 cosecant of x. No vertical shift, no horizontal shift. We're going to do a total of 6 problems. Everybody see the first one? Second one is fine, just there's no vertical shift and there's no horizontal shift. The third one, you're going to do y is equal to secant of x over 2. No vertical shift, no horizontal shift. Everybody see that? The next one, again, no vertical shift or horizontal shift. We're going to get rid of the 2. And we'll do 2 more. It's like those boys need a seating chart back there. This one, just get rid of the 1, no vertical shift or horizontal shift. And this one, y is equal to negative cosecant of 4x. No vertical shift, no horizontal shift. So I'll make that change for next year's class. Still figuring things out. And you don't have to do 7 or 8. So just 6 problems. We'll keep it straightforward and simple. Huh? I'm proud of you. That's your last assignment for this unit. Just a little info. I did some analysis on the last test. If you completed the study guide in its entirety before the last test, the average score was 98%. If you did not complete the study guide entirely before the last test, the average score was 65%. So when we have assignments and we have study guides, there's a reason why we do them. It definitely helps. So you're not going to get another assignment. We're going to look at study guide and practice the next couple days. Please make sure you follow through.